Hello and welcome. I'm Bill Wake. We're here working on a new Swift program. The idea is we're going to try and recognize some index cards from pictures and see if we can manipulate them electronically and maybe kind of work between the real and the electronic versions. All right, today we're going to focus on rectangle recognition. We made a little progress the other day. We got a bit more to do on spiking. Once we get at least, well, there are different pieces we need to get under control, but recognizing rectangles is a big one. If the handwriting recognition works, I'd like to do that. I need to be able to take pictures with a camera, and I need to organize them somehow. I'll probably just start with a linear list and then work my way out to different arrangements. All right, let's go to Xcode. Oh. It's I have something to automatically change my background or my screen size, and you arrange all the windows and then do that. It's like, doesn't work. Okay, let's see where we left off. We're really just trying to understand the vision stuff. Okay, so let's find that. Okay, here we get the rectangle we're going to draw, and then okay, when you press go, we're identifying rectangles on the thing. So you do that with a rectangle request, and then you can basically ask for the observations, and then we're trying to draw a rectangle on the image. Okay, so we left off there. So all that is set up. This thing actually executes a request, and when it succeeds, it calls this function. So the request has a callback function and pulls out the results, prints some stuff. We had it drawing a bounding box, which I need to double check. But we had it drawing a rectangle like this, like right after the show, I think last week. I don't think we did this during the show. I remembered like, oh, there's this overlay thing on images. You can draw a rectangle, you create an overlay and you can draw a rectangle there. So we're drawing a rectangle with a red line based on the width of the image and the height of the width and height of the bounds. Let's see, bounds dot width. I mean, it's certainly possible I'm messing this up. Geometry is the overlay itself. Bounds, where's that coming from? We'll have to see. Okay, but anyway, one way or the other, we're drawing a rectangle reflecting where this rectangle was found by the vision stuff. Okay, and then up here, we're just identifying the rectangle. I think I changed the name. It was yacht.jpg. I put in a couple more examples, or another example. So we have one image like this, and then I mostly just rearranged the cards to an image like this. So the first one was more horizontal, and this one's more vertical. This is the one we're doing recognition on. So I would love to take these two pictures and say, hey, recognize the same cards between them. Category 1, some of the ones, and so on. Category 1s, category 1s through 6s. Okay, yeah. So all that stuff, I would like it to recognize like, hey, these are the same cards. I'd also like it to draw rectangle boxes around the things. Okay. Now, when we run it, this is what we're getting. We're getting our picture. That's the image, and then the overlay is showing where our vision searcher found the rectangle. Okay, I think we got to double check that, but it looks off to me, and I'm sure it looks off to you because it's chopped off this box. Now I would have thought the contrast here was pretty darn good the dark red versus the white. So I'm suspicious that um, maybe I've somehow got my math wrong on where I'm drawing this. It's we talk about realms of possibility. It's definitely possible. But what I don't see is like if I reverse the image or I flip it vertically, it doesn't really fit like anywhere. Okay, so let's pick up there. Oh, let's see. I did one more thing. Content view. All right, somewhere there's something you can set to say, I want to get all the images. Yeah. Maximum observations equals 0. Okay, so let's run. Oh, I guess we are running. We got go. Okay, and it ran, and hopefully it printed somewhere. Now, I would have thought that would be here. Make sure we got a console. Activate console. That's what we're looking for. Okay, so this time, I don't know what these F opens are. I find them discouraging, but there you go. All right, but here we have image bounding rect 0.018, 0.71, 0.20, 0.21. Then we have TRBL, which I think is top right, bottom left. But it's 4 points. I'm not sure what that is. Then we got the horizontal. I think that's the translation I'm trying to make. And so height and width and more. And notice these are all different things. Okay, so 0.018, 0.315, 0.108, 0.0399. Okay, they're just all different places. So one thing I think we could do, it would be nice if we took all those observations and drew rectangles for all of them. I'm hoping that lets us realize, like, hey, it's got 3 across and 5 down or something like that, that tells us like, oh, you've done clearly stupid arithmetic mistakes. All right, let's see if we can figure out what we have and where we're going. Okay, so when I draw, all right, so what I get back, let's find those bounds. Where is bounds? Okay. Oh, I've hard-coded it. No wonder. But I've hard-coded it to the values that they're using, right? 0.018. Well, I haven't done very good at that. Let's try 0.018, 0.712, 0.202, 0.211. All right, that should give us a different look. Let's see if without transcription errors it looks any better. I don't know. I guess this is XY with height, right? Okay, interesting. Unfortunate and interesting. Now, where does this box belong is my question. It's clearly not right on the X coordinates. It should be an overlay. I mean, my interpretation of what I've done is it should be an overlay to this image. All right. Let's see, what can we do? Okay, so right now the button is just the button is triggering the vision thing to run. The bounds are coming from the hard-coded values here. Now, what's really puzzling to me, yeah, I'm definitely puzzled. So with 0.202, height 0.211, that's practically the same. That does not sound like a 3x5 card. Are these things coming back? We need to make sure like our units are right. Okay, so a bounding rectangle. What type are you? Do you tell me? I got used to Elm lately. I've been doing that for the last few weeks, and you can hit Control or Command P, and it will tell you the type of the object. I'm sure there's a way to do this. Well, let's just say it's CG Rect, and if it's not, then it'll complain. Okay, so apparently that is CG Rect. Bounding box, CG Rect. Okay. The bounding box of the image, they're normalized to the dimensions of the processed image, origin at the image's lower left corner. Let's see, Astrid. Would it help to draw the boundaries of the scanned image to check whether the scanned image is obfuscated? Well, I think the boundaries are the boundaries of the image are right. Okay, let me let's see. One thing is confusing to me. Origin at the image's lower left corner. I don't know if everything is consistent across that, but let's see. Draw the boundaries of the scanned image. Yeah, let's add that in. That's not hard to do, and it will answer the question instead of me speculating. Okay. Resizable aspect ratio. I think I can dot border. Content. I kind of want this one. Content of shape style. I think I can say like color dot green with :2 being pixels. Thanks for joining, Astrid, too. All right, yeah. So I think the boundaries here are right, but you're right. Maybe this is. How can that be? How can it be off the boundaries here? That's a really good question. I mean, yeah. So the way I'm trying to draw it, for better or worse, I'm trying to draw it relative to the image in here, and I guess this is saying it's going to be relative to the bottom left corner, right? Is what it said. Lower left corner. Aspect ratio is set to fit. Yes. Let's double check that. Yeah. So, well, the reason, if I weren't confronted by something that doesn't actually work, my understanding is anyway, the image, like whatever I do here, I get so far, I've got the image, whatever it is, it's resizable, it's going to retain its aspect ratio. So there are other modes that like squash it to make it square or chop it off or things like that. So fit says get the whole image in the space you give it, which is the screen, whatever's left over after the hello world and the button. I put the border on, and then Geometry Reader should get the coordinates of the rectangle itself. So it knows it's a way to pass in the geometry of whatever size it's going to assign to you. Now, the bounds, let's see if we can we see our console again? Where'd it go? Oh, I got to hit the button. Okay, so when I do this, notice they're all 0 to 1. So I'm interpreting normalized to the dimensions. I'm interpreting that to say, this is a percentage basically of the width or height. Now, this is XY with height is the CG Rect. We can see that up here. So XY. So in my terms, I don't understand how it draws outside the frame. Okay. Position. So the rectangle we're drawing. Yeah, let's try that. Okay, I'll just replicate this one. Whoops. That's what I want. Okay, so 0. Invalid redirect version. Yeah, whatever. Okay, let's run this. So I'm expecting that to be, I was expecting it to be the whole square. Now, I'm doing the position. Obviously, I've selected the position 0, 0 up here is what I'm assuming. Let's do 0.5 and 0.25. Okay, I'm not sure what that means. 0.5. I would have thought let me just go look at CGRect and make sure I'm not interpreting that wrong. Origin is a point size. I can give it x, y, width, height. Okay, so well, one thing we can definitely tell. Well, two things we can tell. When I had the 0, 0, it was drawing over here somewhere. We couldn't tell if it was cut off. When I say 0.5, I expected it to be half. I expected it to be halfway across the screen. Okay, so I'm going to go back to the 0, 0, 1, 1. I like that idea a lot. All right, so I should be x, 0, 0. Let's do it again. James Blinn is the guy that did a lot of the early visualizations of flybys of the planets for NASA and stuff like that. And he has this thing about, it's very easy to multiply by -1 the wrong way and get your coordinates flipped because, the top's at the bottom or the bottom's at the side or it's backwards left to right. It's like, what you got to do is just go in there and be very careful and keep track of which one's which and when it's flipped or not, and then run it and see what happens and throw in the extra -1 if you need it. And I'm kind of in that boat here. I think we're not seeing the edge of the red. I kind of feel, and maybe this is me imposing, I feel like the size of the red box ought to match the size of the green box at this point. And if I were just placing it correctly, that would be the case. So, but when I look at this, I don't know, you can't see my hand. I feel like the line in the middle seems to be pretty much right down the middle because Go and Hello World are centered, and it looks about like the width there. Okay, so it seems like a 0.5 width somewhere is going on. I can't tell. So I think this is probably 3/4 of the box. And this vertically, I think that's also 3/4. So I've somehow cut off a quarter. Let's see if we can get this math right before we go too far. Okay, so the question would be the frame. All right, let's make sure I'm multiplying the widths by the right things. Okay, so bounds.width is the dimension, the horizontal width of the red box. Okay, geometry.size.width should be the width of the image itself. Okay, so if I multiply the image width by the real width, the bounds width is a percent kind of thing, 1 being 100%, I should get the same width as I want. Geometry size height times the bound height. Let me just hide this piece over here. It's not doing much. Okay. Geometry, even though it's a spike, I can't get by with being lazy. Let's take this. Okay, geometry size width, height times bound height. So I think I haven't mixed up my x's and y's anyway. All right, now on the position, the x is the width times the bounds minimum x. That does not seem right. The bounds is a CG rect, and we want the width. We don't want the width. This is position. Let's modify this too. Okay. So if the position were, let's just make it 0, 0. I mean, that's what it should be if it's in the bottom left corner. Okay, and let's see what that looks like. So I'm trying to get it in the bottom left corner. Yeah, I haven't changed it. Go doesn't do anything to that. Why did that not affect the position of the rectangle? Oh dear. Okay, keep me honest, Astrid. Do you see the problem? Okay, so I would have thought if the origin is 0, 0, and I drew the box from that position, I should draw the box at the bottom of the thing. So let's see what position does on the image thing. Maybe I have to flip the, like, invert the bounds. Oh, where can I find this? I guess I got to go look at, well, it's probably shape. Oh, maybe I can do it on the position. Definition. I really should know where my drawing stuff treats its positions. Okay. Oh, position's the center of the view. No wonder things are messed up. Okay. Place the center view at a specific coordinate in the window using X and Y offset. Positions the center of this view at the coordinates in the appearance coordinate space. Okay. Well, spotting the problem, that's a pretty good thing. Okay, I think there's definitely something going on wrong here, right? Because this thing is talking about this position is the center. So that explains something. So yeah, this is the center here, 0, 0, apparently. Now, why that is here... So what's confusing me I guess if the bounds is in 0, 0, the bottom left corner, presumably relative to its view. Okay, maybe there's a different position thing than this. Let's do the old search technique. That's what I want to do. Right to their top left corner. Well, no, that's not. Offset. Let's put offset parenthesis. Okay. Yeah, so 0.5 shifted to the right edge. Yeah, maybe I should just do them both 0.5s. Okay, so the bounds, I believe, is drawing from the, well, is that your side? Bottom left, and saying, here's my width and height to get me out here. And if I position, well, maybe I should just position, like, get the width and height going on in here. If I knew the geometry size width, all right, let's try 0.5, 0.5. See if I get any insight from that. Okay, and I should be predicting, and I'm just kind of like at a loss. Okay, that's in the upper left corner. Okay, so we'll do the other. 0.5, 0.5. No, the width has to be the width. It's the X, it's the wrong one. Okay, oops. I'll stop. Okay, but the position, I want the center to be, I guess I want it to be the true center. Yeah, maybe that's true. Theoretically, that's saying the middle. I mean, because this thing's defined, in percents. So another one to try. Okay, didn't expect that. But carrying on. No, okay. All right, so let me see if I can do the math on this. I hate thinking, but all right. So if the bottom left corner is 0 and I want to draw, I want 0, 0 to be the bottom left corner, but I'm at 0, 0 is the middle. So I think I've got to somehow subtract off the width. Okay, that's the width, X the width. Okay, if I put the thing at the width, it's going to be centered all the way to the right. Is that going to help? No, it's not updating. I mean, I'm moving it around. The width looks right, so that's something. The width, the height is plausible. Okay. Now maybe this is. Oh, that should be -2. Yeah, there's no update. The go button just runs the analysis. Hey, look at that. The go button runs the analysis and prints all the points, all the rectangles that it can find. Okay, so I I think let's go back to the one we had. Do we still have? Yeah, let's run go. This just prints the command line, the console. So there's um, no reality, no interaction at this point. Okay, but I'm going to do this 0.018, 0.71, 0.2. I should just do 0.02, 0.71, 0.2, 0.21. Well, I got them right here. Actually, got it right here. Okay, let's see what this does. Okay. Yeah, something's funny here. I mean, I would. All right, let's see what the point is. X is 0.02. Okay, so to me, x.02 should really be this left edge somewhere. Okay, and then the size of it, I can plausibly believe that matches my card there, because I think this is x.02 should get me here, and y.71, ooh, that should be 3/4 of the way. I think that may be this point here. So width and height look plausible. I mean, I'm not 100% sure, but placement is still messed up. Okay, let me go back to this. We will add a blank slide. Okay, so I'll just put a shape on here. That's more or less our picture. I got to get a happier color. Okay, so 0, 0 is here. Okay, and that's my coordinate on that's the position in overlay. Okay, my bound box, my vision results. Okay, they're going to be another shape, kind of a 3x5 cards type shape, and we'll go with a mild color here. I would expect the coordinates to be like I guess I would say CG rect, and it would be like, I don't know, 0.1 for X. Let's move it up. Maybe 0.3 for Y. And then I'd say 1, 2, 3, 4, 5 of these 0.2 width, and let's just say it's 1, 2, 3, 4. Well, it's probably 5 that way too, but let's just say it's 1/4. Okay. All right. Now, I think the problem I've got something. No, so, yeah, it's drawing in the center. So I think the issue is this is I'm not. I'm telling it where 0, 0 is. I'm telling it where the center is. I told it the center was there. I told it to position itself. I think that's the saying, position yourself at the center. Because I just said 0, 0 is there. I'm not sure I added anything. But I really need to do like minus or plus. See, I got my signs going already. Somehow I should be getting the bounds. The position should be based on the bounds X, right? And we're not basing it on that. We're basing it on the size of the picture. So I want to say it's, well, somehow it's got to be, okay, I'm gonna split out this stuff. Oh no, I'm not. It's functions. Okay. The X position, if the middle is smack in the middle, 0, 0 is smack in the middle. Okay. If I want to be, well, I think I've got to do something like this. This times bounds dot X. Bounds dot, what did they call it? Let me go back. The origin. I assume this is just XY. Yeah. Okay. So, well, min X is not the worst guess there. The lowest point on this thing. Okay. This should be right in some direction. Oh boy, no, it didn't move. Yeah, that's kind of what I'm trying to do. Transpose the XY of the rectangle by width and height halves respectively. So I'm feeling like I want to add, okay, what can I do here? I guess if I don't know what the answer should be, there's no reason to think I would get it right. Okay, so if this thing is 300 wide, the whole geometry, okay, if I get 0, 0, I've got to put it at minus the bounds, right? I don't know why this is, okay, geometry size width divided by 2. Well, if I take the width, yeah, 0.18, that's the X coordinate, right? Yeah, 0.18. So the minimum X should match the X coordinate of the origin because it's theoretically drawing a box from there, I think. If I take the width times the bounds, that should tell me if you started at 0, where should you be? But maybe I got to add that? I think adding it's going to go the wrong way, but going the wrong way would be progress. Okay. Well, that doesn't look like it went anywhere. That's still centered. Okay, let me try another experiment. Okay. If the origin of 0 is this, see if I can just manipulate the x-axis, because I'm not doing very good at that so far. I don't get it to do that. No. Okay. I sent it off to Nowhereville. All right. Yeah. Okay, if it's 300 wide, the width is 300, the bounds min x, well, it's something. If I take that, I believe, okay, yeah, let me just focus on this piece here. So if it's 300 wide and my bounds is 0.1, okay, then I should get 30. So I want to be, the width divided by 2 is 150. Puts me there in the middle. If I subtract 30, I'm not in the middle. I think I got my subtractions in the wrong order. But I don't know. That min x might be 0. Yeah, I don't know. Maybe I can debug in, but I think if I take the size width, that should be 30 if it's 10%. And if I subtract, I hope I'm moving it to the left and not just arbitrarily. No, I'm too far again. Okay. Min x might be 0. I don't think 0 is a problem. I mean, if it says it's at the far left corner, 0, 0, it's saying that's the bottom left corner is 0, 0 on the thing we get back. I'm gonna switch gears again. Let me see this offset. What was my search? It was like, I didn't really get a good answer. Position relative to top left corner. All right, this site is always good. Offset Y15. Text before, background color red, offset that. Well, I guess we like before better. So I think the offset -5 there is pushing that in that way. All right, let's just try offset and see if that makes more sense. I don't know. Dot offset. X colon. I'm going to steal this. And let's just see where we get. Yeah. Oh, okay. I was trying to get the X offset, so that seems promising. Geometry size width. Okay, let's put the Y and see if that works too. Okay, so I'm going to assume it's the same symmetric size dot height times bounds dot min Y. Okay. That looks like how far down it should be on yacht to me. Okay, if I did okay, so the min Y, maybe that's not the right. Well, no, it's 0, 0. See, I think I'm flipped somehow. It looks like the coordinates on the X. It looks like the coordinates are coming in from the top left. Yeah, let's try this. Minus that. Oh, close, but not there. So geometry size height times bounds min Y. If this thing were in the bottom left corner, it would say 0, 0. And the Y. Okay. If it were 0, 0 down here, it really should be the height. Okay. So I'm thinking this maybe is 1 minus bounds min Y. Okay. Okay. Normally we take a break. I think we'll just take a 2-minute break. I know we've been slipping these things the left and right and the other. I think when we get a couple, when we get all the rectangles on there, I think we'll know if we're right. If we get it right here. Yeah. I'll feel better seeing 2 things come out right than just getting 1 right, because I'm sure we can play with it in wrong ways and do it. But anyway, we'll take 2 minutes and come back and get this thing into shape and get the rest of them going. I'm sure that'll feel like real progress to see 9 little rectangles on there in the right place. All right, I know that's a little short, but I'm going to delete all these because I think position is just throwing us off, but offset is close. Okay, so if we're at 0, 0 in... Maybe I have to draw the 2 coordinate systems. Okay. The vision system thinks that this is in the bottom left corner. The offset, I think, thinks it's up in the top corner. I think this thing thinks this is 1, 1. And I think this is in the pixels or something approximating them. And if my image is 500 wide by 300 or something. Does that sound right? X should be 500 over here. Y should be 300. Okay, I think this is what we're doing. Okay, so we have something that's a percentage from here. So down here is like 0, 300. Maybe I should put that in too. And we know we can treat X and Y separately, so where are we? Okay, 0, 300. Okay, and then up here, X is still 0 and it's 1. Okay, so when we say 0.2, if we're talking about the bottom left corner, that's 0.2 is over here horizontally. Okay. And the percentage is, so X, that maps pretty well. They're both mapping to the right for horizontal. It's the vertical that's thrown us off. So if I want to map 0 to 300 and 1 to 0, okay, I think I'm saying 1 minus this. Okay, 1 minus this times that. Does that give me what I think I want? Okay, so if I'm here at 0, 0, 1 minus 0 is 1, times 300 is 300, should put me down here. So 1 minus y times the height. I think that's what I said last time. 1 minus y times the height. Okay. And what did we get for a picture there? Random stuff. Okay. 0.02. So X should be just barely across the grid. And I think that's probably right. The X coordinate. The Y coordinate is 0.71. 1 minus height times percentage. Well, the height is in the 300 range, right? So height times percentage should give me that, but I don't think I can subtract it from 1. I mean, I think 1 minus the percentage should be there. Okay, so let's see. 0.71, that should be up. So the point we're talking about should be up in here. Let's get a little red circle. Okay, so if it's 0 on X and 0.71, I mean, something in here, kind of 3/4 of the way up. That should be the start. That should be the lower left of his thing. Now maybe I'm not drawing him the right way. If this is 0.71, I want it to map to 75-ish here. No, that can't be right. 0.71 is really 0.7 is 0.3 going down. So 0.3 times 300 is about 100. So this should be about 100. That should be the bottom left corner of my thing. But I think somehow I've got my direction going. It's still going. Oh, I get so confused. I appreciate your patience. I think my rectangle is the bounds. According to the bounds, it should be drawing from here up to here. I think when you flip the coordinates, we're providing the boundary we're providing the flipped value is the top left. All right, let me 1 minus, let's do this again temporarily. I'm going to pretend it's in the same coordinate system. It's not. Whoops. All right. I think if I were to flip the picture vertically, I would be happy. Okay, so let's see if there's a way to flip a picture vertically. And then I'm going to flip the whole thing. Okay. So resizable aspect ratio. Okay. And then, I don't know, is there dot flip? Flips for right to left. Flips its contents horizontally. Oh no, that's for like Arabic. Okay, I'll cheat and look. SwiftUI flip image vertically. I don't want to rotate. I don't want to scale. This is almost it. Yeah, that's the kind of thing I got to do is translation. The kind of thing I used to know off the top of my head. Probably 30 years ago. This is not, we don't have a U image. We have an image. So it's not really answering SwiftUI. Let's see what we got there. Total rotation. Rotation effect. Okay, so there's something on shapes that does rotation. There's got to be something on shape that does the rest. Image. Let's see. Is it just the point the wrong direction? Height could be negative. Yeah, I think our height. I feel like we're trying to give it where we want the top left corner to be, and if we flipped it, maybe the second rectangle would help. Okay, jump to definition is apparently not going to. Let's see. Custom reflectable. Can I go back to rectangle? No? Okay. I don't know how I get there. I mean, normally, like to flip it, I remember you do -1 somewhere in the thing is A, B, C, D. Right? These things, they're a little weird because you put your point and then you add an extra one column, and then you're focused on these tx, ty. So that's translate, I assume. Yeah, x prime equals ax plus cy plus tx. So that tx is translate. If this is -1, right? We're flipping them. Oh, translate by. Oh, scale by. This is promising. Maybe scale by. Scale by multiplies. All right. It'd be nice if you told me what it returned. Okay. Let's get our drawing. Oops. All right. We got our drawing here. It's doing something. Let's do a scale by. Sorry. Okay. Scale by. If I scale by 1 x1 y minus 1. Let's just see what that does. I messed something up. Member view has no member scale by. Let's see if that was just too generic. No. Who has scale by? Was that on CG context? I don't think I get to see the context, so okay. But I got to do the same thing. Oh my gosh. I got to go back to this. If I want, I'm going to put a red box here too. Okay. I want this thing to be like that-ish. The dot tells me that's where my corner is, and I want to extend by the width and height. Now, if I'm in this dimension coordinate system, increasing goes down. So giving it the width seems okay. Maybe I'm not. Care about blending. Yeah. I'm sure there's a way to get down and use this. It's really not. We're not really at the core graphics level. We're one or more levels up from that. So I'm not sure I can fight my way down to that level to make use of it, but it's close. Okay, I guess I lost my window. Yeah, I don't think it applies to this stuff, because like this image, I mean the image itself, Okay, I need to just think through the math, I guess. Okay, so if I have this, okay, maybe I got to do it down here. This is what my bounding box is telling me. I'm a little confused, actually. Okay, let's say this is 0.1, 0.7, 0.75 or something. Okay. If it tells me I wouldn't expect that. I would expect 0.1, 0.3 here. Okay, so I expect to take 1 minus my percent they gave me. So it's 20% up, should be 20% down. So 1 minus 1 minus the y coordinate should give me the percent down in this one's coordinates. Okay, so if I multiply that by the true width, I should scale it to that. And I think that's what I tried to do. 1 minus the bounds y. Oops. One minus the bounds min y. That should give me, if I was 0.2 in the bottom corner, it should give me 0.2 in the top corner. And multiplied by the height should give me in real coordinates. Okay. So I would expect, I expect that to be at the corresponding place at the top. And it's not. But I wonder if I'm getting here. I wonder if I'm getting at the top left corner. All right, I'm going to throw it in, and I maybe the min y, that's the origin. I'm going to subtract or add. Yeah, can we try a negative height? Oh, let's take. So a negative height on the y coordinate, or on this. So is this what you want? On height. Up here. Okay, and I'll negate the whole thing. Just to be very sure it's doing the whole thing. Okay, so I think he's off screen. Oh yeah, he's not happy. Negative. Oh, it doesn't like negatives. Okay, but I think maybe the negative goes on this. I'm almost thinking it's the min y plus the height. Bounds.height. Okay. No, I don't. Okay, I can't even type a proper expression. One more. If this had happened like that, last Friday at the end of the session, I'd be very happy. Now I'm just not so sure, but at least it looks like it's grabbing the right thing. Because before it was drawing over halfway over the square. It's like, okay, that cannot be right. All right. Now, what I want to do is plug in coordinates from one of these other things and see if it grabs a different square. Okay. Okay, 0.44, 0.15, and I will duplicate this, I guess. Point 0.44, 0.15, 0.17, so it's a little smaller, and 0.19. Okay. If we live right, this will mark a different rectangle. If not, I'll just excuse myself and go pound my head somewhere. Okay. I feel much better. Thank you, Astrid. Oh, I think if we'd been able to be in a room and draw rectangles together, we probably could have gotten here, in half the time, but I think we're here. All right. I can live with that. All right. So let's check this in. It's progress. Okay. Okay, so we've successfully marked a rectangle based on the vision system's findings. At last. Yay. All right. Don't want to lose that version. Okay. Now, let's clean it out. Even though I'm thinking of this as a spike at this point, I want to push it a bit further. Okay, the offset thing is right. I think we're at the right place here. Okay, now, yeah. So I think I got to convince myself, and because I believe it because it's already here, that's it's almost like cheating. But the frame, you take the width. This is the rectangle we're going to draw. We're going to take the width of the actual image, which is coming from geometry. It's really the bounding box of the thing you're in, and the bounds width tells us how wide it is relative as a percentage, and same thing on the height. So I think the size of our rectangle has been correct basically the whole time, so that's cool. Now this one, the x-coordinate, we're multiplying it because it runs 0 to 1 on the bottom, and if we multiply it by the coordinate, we get however many pixels it is over. Okay, offset. Now the bounding one, this one, we're taking the height, okay, because it's got to scale from 1 to the height, so it's got to multiply by the height. Then we're taking the bounds min y plus the bounds height. That moves us up from the bottom left corner up to the base of the height of the box. Okay. Then we multiply that by -1. So however far we are from the bottom, we flip it so we're that far from the top. And in effect, our rectangle is flipped over as well. So I think that's what that's doing. Yeah, but like I said, if I typed it in this way and believed it the first time, I'd be happier. But I am. Let's see. Let's do another one just to make triple sure. We'll just grab one of these other ones from here, and see if these coordinates work any better. Okay, let's just steal this. We'll be highly accurate. Okay, CG rect. I'll comment that one out. CG rect and paste what I got, and that is, well, it should offer to fill it in for me. Yeah, fix. Okay, and we'll run this, and this should be yet another box marked. Okay, that is cool. I kind of wish it would like tip the rectangle, straighten it out and everything for me, but maybe I got to do that myself. Maybe I can live with it like this. If you're normally putting stuff in rows and you're more or less horizontal and vertical, that's okay. Okay, next thing I want to try. Let's switch images. So instead of yacht, let's do yacht 2. Yacht 2. Okay, I don't need hello world anymore. Take that out. Oops. All right, let's see yacht 2. And it's going to draw the wrong box. Okay. That's a box. Yeah, we got to hit go and got to find a box here. Okay, so go and ooh, it's not finding very many. Only found 3. Ooh. Okay. Replace this. Let it fix it. Crazy face. Not really what I expected. But, I think what we're fighting is I did this is on the back of a quilt, and the quilt just happens to be it happens to have that white line connecting them. Apparently it's strong enough to make it believe that. But I would have said 1, 2, 3, 4, 5, whatever that is, 6, 18, 19. All right, I'm gonna take the other ones and let's just see what it's coming up with. I don't expect it to be perfect, but I expected it to be better than that. Okay. Height equals 1100 something. That just sounds wrong. Okay, fix. Okay. Now I may do it. Am I doing anything funny? I don't think so. I was worried I might have hard coded some image size or something like that. Okay, let's go find the last one. .56, .34, .2, .3 sounds pretty big. Okay. So I'm getting some picture of how sensitive the image stuff is, I guess. All right. Yeah. What it tells me is it's great that we have the automatic vision, but I probably am going to have, in a real app, I would probably have to have some way to let you place your own rectangles on the ones it missed. Oops. Run this. Oops. Run this. Okay, so it found that one. That one, you can see why it's all. I mean, it's very close to touching. I can believe it would, not. I would believe it could need a little more separation, but I would have thought it should find. I mean, even if it had just said 3 columns or 4 columns, I wouldn't have been surprised. But okay, so Yacht 2 is not the best picture to work with for this, at least at this point. But we know what we're going to be up against. All right. Okay, so I think, let's see. I've got options, and I should probably be reflecting on that. So find rectangles in a single image. We continued with that today. But I think, well, I got multiple things going on in my head here. One of them is some sort of basic card UI, just a list list of cards and a swipe to move between cards. Okay, and I don't know if it's horizontal or vertical, but I'm just imagining I'm holding my phone, just flick, 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 flick. If it were flashcards or something, I'm trying to make a kind of minimal app in my mind. All right, so I definitely want to do that. Another one I definitely want to do is take a picture. Okay, so if you were using your phone for this and you drew some index cards, and you should be able to either take a picture of a card or a board and get it going. Now you can't put white cards on your white your white whiteboard and expect this to work. You're going to have a contrast in color. Might even be okay if you had colored cards on a whiteboard. I don't know. All right, so take a picture, and then I want to show all identified rectangles. Oh, and I also want to see if there's handwriting recognition. Okay. Let's ask that one. So iOS handwriting recognition. I don't know if it's a built-in thing or not. I looks maybe. What? I seem to have lost my query. iOS handwriting recognition. Input from Apple Pencil. It's not that. Although that would be a nice thing, wouldn't it? The thing with the pencil is because when it's going up and down, depending how much it's got in it, but the sequence it drew things, so you can kind of make different guesses than just being confronted with, an image. Yeah, that's not what we're doing. Okay. Handwriting. Yeah, that's nice, but stylus. Handwriting. Let's say image. There are apps for that. Live text OCR. I'm not sure OCR is going to be. Yeah, I'd be very shocked if OCR could make sense of my writing. I've got sigmas in there, and if I'm saying turn, you could believe that's turn, but I mean, I could be more careful. Let's scribble again. Okay. So maybe, my quick spike there, I don't think I have handwriting recognition. Maybe with Apple Pencil. Scribble interaction XD. Oh, was XD right? Yeah, I think scribbles only come from using your pen. I mean, it might be fun to put in. I mean, the theme I have on this is kind of blending the real cards with the virtual cards, and I could absolutely see giving you a writing surface to write your own card on like that, and then we could print it out if we wanted to get a physical card. But having that written, that could be very nice. Um, let's see, what else have I got going on? Show all identify rectangles. Take a picture. Basic UI. I want a more. I want. Well, another one I want is more UI stuff, but flip a card and write on the back, and write or type on the back. Okay, I want you to be able to correct things. Oh, okay. Be able to correct things and maybe add metadata and stuff like that. And then another level of UI is, is kind of manage cards on a surface. Okay. And then another level I might want in. Oh, yeah. Yeah, that's a good example. Split cards. Split cards, move them around. Maybe have a couple like stacks. I don't know. There's different interactions I could definitely see us wanting. When I'm taking cards like that and trying to arrange them in like what did I hear? Beck talked about it as like solitaire. How you play solitaire and you move cards here and there and try this configuration and that configuration. That choosing stories can be that same sort of thing. You've got a bunch of stories you want to do, and you decide, well, what if I try and do the easy ones first, or which one's the most valuable, and you rearrange cards and try and decide that. That would be nice. Okay, so and then I don't know. I have another idea, and this may be a different project too, but I'm sort of imagining this with an iPad, and I would love to take that giant stack of cards. Well, sorry. I'd love to take a layout of cards like on our image. Okay. But I would like to, I'd like to kind of use my mouse and flick them around and rearrange them and do stuff. But they might be hard to read. If this is 19 cards, if it were 100 cards, they'd all be too small and it would be hard to work with. I would love to pretend, use the VR stuff or the some of the detection of rotations and stuff on iPad, but present it as if it were on a wall 4 feet away, and then use my iPad, move it forward and back to zoom in or something like that. So not VR. Let's say iPad as a view portal or something, move closer to zoom. I don't know. We'll, the way these go, I think we can identify rectangles on, what we saw was this is too hard. The other one seemed doable. The image, let's see, did I put it back to Yacht 1? Yeah, let's run this again. It tells us how many it found. So let's make sure it finds 4, 8, 13. I don't think it found 13. I think it found 9. Yeah, it found 9. So some of these are probably too close or something like that. Okay, so it's got to be spread out a little to give this image recognition a chance. That is showing us the coordinates we used in the old test. Okay. All right. So I'm going to, let's see. I don't know. I think at some level, okay, what have I done spike wise? I guess I got to look at that. All right. I think what I've demonstrated to myself is I can compose a request and fetch it. I could create a handler and fetch it. And when I do that, I can get back the list of all these observations. Okay. So I think that part feels okay. Now, I haven't worried about which thread is which and all that kind of stuff. Okay. Um, what else? All right. The bottom half here, I think, between this stuff, that's sort of giving me this stuff in the output. A list of all the rectangles it's identified and what to do with them. All right. Now, this is more the drawing stuff that goes with it. I've just done a simple state with one variable, a CG rect. I could imagine, the next step in this would be make this an array of rectangles, and when you call the identifier, then it produces the array of rectangles, and that's what you're seeing. And so we would get however many it found, we would get all those on the list, highlighted and stuff. That would require me, instead of just having one overlay or one rectangle, I probably have to. Well, I have to have a loop somewhere to go through all of the coordinates. Okay, so this gives us for one coordinate, what would it be? Yeah, so I think yeah, that'd be a reasonable next step. I think I want to get out of spike mode though. Is kind of what I'm feeling like. We wandered around, trying to understand the fact that there's two coordinate systems and how they interact and stuff like that. Why they do that, I don't know. But that appears to be what's going on. All right, so I think if this, what should request do? It should leave an array of CG rectangles somewhere. Okay, now maybe we have to hard code it. Have to hard code where it writes to. I'm not quite sure what the requirements of that are going to be, but I do feel like we can encapsulate this to some extent and say, okay, I can't test the internals of rectangles, but I can at least get back the boxes for them. And maybe that process should include this stuff too. Like, I think if this thing produced, well, yeah, if the request produced me a list of rectangles in the coordinate system of the image I drew, I would feel pretty good about that. I don't want to be decoding those in my drawing stuff. Okay, so let's. I guess this is, I don't know. It's going to be like more like a refactoring, but gosh, there are. We're not saving anything except. Oh, we're not saving anything. Okay, that explains it. This thing. Okay, I always gotta keep this straight because this thing. This is a closure that's being passed in and then called once it takes the request and figures out the answers. Okay. But well, I don't mind refactoring a spike in the sense of, kind of trying to get the pieces out, but I definitely need to refactor this stuff or start over. It's okay either way. But what I think what I'm trying to identify is we have something that gives us rectangles that we can use. I think we want to say what would be the right interface for this from our perspective. Like I want to go to somebody and say, here's an image, please tell me the rectangles. That seems like a valid request. Okay, so let's, and yet, okay, I guess the place I'm choking up a little bit is I think I can encapsulate that much. Okay, but I feel like getting these let's see, it's the bounding rect. That's coming from right from the observation. Okay. I think the rest of this was me trying to make sense. Well, I could draw the rectangle based on that. Okay, because apparently that used the same coordinates. But none of this stuff is of any use to us in our bounds. All we did was take the bounding rect, this thing, and I pasted it in and pasted, let it generate the XY width height that needed. All this other stuff is just stuff I was learning on the way. So I think I don't know if I can feel like I can TDD this part per se. Like I mostly just want to trust that those three lines and encapsulate them. All right, so let's at least, yeah. So okay, I don't mind those three lines if what they did was somehow three or four lines got me a list of bounding rectangles. Now, the fact that the coordinate system is backwards and it's 0 to 1 instead of 0 to height and all that stuff, I think I can. I feel like I want to do this transformation in whatever I'm encapsulating, but that can be tested. I mean, that's clearly, we're getting that directly. I mean, somebody's thinking about it. I don't mind multiplying by this is converting the 0 to 1s to whatever's, the real scale. But this computation in particular, I want to do. Okay. So I'm going to say, let's see, let's invent this class. All right. So we're going to put a test because there's definitely computation we're doing. All right. So let's make a new test. Now I've got this is John Reed put this together. So just a dummy test for you. All right, so I'm going to call this Vision Rectangle Finder. Maybe just that may be a little ambitious. I don't know. Okay, Rectangle Finder. All right, so I want to say. Okay, what do we got? This all looks all right. Okay. I want my test to be, if you maybe it's find bounding finds bounding rectangles for image. Okay, and this is going to be a little more. Yeah, the view shouldn't transform raw data. Unfortunately, well, maybe we can. Let's see what we want to do. All right, I'm thinking of this more as like an acceptance test or almost like a pin down test. I don't know. I don't want to test the library, but my query is different than the library. It's like there's a little bit of stuff going on, but I'm just going to say whatever the coordinates it gives me for this search is the right coordinates because I don't know what they should be. Maybe I can create a simpler image. Let's see, we got these. Okay, these are pretty well. Oops. That one's impossible in my mind. I have this wooden rack that you can put cards on, and there's almost no separation, right? You might say those are separated, but I think every other card on here is touching another one or overlapping with it. But Yacht 1... I mean, if I extracted a sub image that was kind of like the first two cards, um, yeah, a black and white image, um, yeah, maybe something like this even. Let's make a new page. Oops. Okay, so let's just take a shape and we're just going to put a couple of cards on it. Oops. Another shape. I'll fill it with white. Okay. If I had this, copy that. Yeah, nice idea. Just black and white. Make it easy. Okay, we'll paste that. How big is it? Kind of big. It's okay. I'll export this, and I'm thinking it seems like we're getting JPEGs probably from the camera. So this is two cards JPEG. Okay, I'll just put it on my, well, I can put it in, I'll put it in here with the others. So they got the images up here. Okay, fine. All right, let's get back to Xcode. I think if we change this to that one, I guess I gotta, whoa, didn't go there. Yeah. Where did it write? Am I still in GIMP? No. Set JPEG. No. Cancel that. Maybe I have to go up one more level. Okay. To go to that JPEG. All right. Let's search that one. Okay, if we run this, I expect that to find two images. We'll capture those. We'll put those in the test, and go. Okay, so it found two images. I'll just grab all this and sort it out later. Okay, so in our test, bounds one equals CG rect of that. I don't need this or this. You ought to complain. Okay, there we go. Fix. Okay. All right. So all right. So I want to say let finder equal rectangle finder of, and I think I want to give it I think I want to give it a UI image. UI image named that. Okay. And then I want to say, I guess I'm going to say the Finder has Finder rectangles. Thing is, I don't want to. I don't know. I feel like I'm testing something internal, but if I create that Finder and I say finder.find, I'm going to say I'm getting this back. Okay. And my assert is, I think it seems to find them in order consistently. So let's just assume it will, and we can deal with it later. Do I have an assert equal? I got equatable. Okay. Rectangles to be equal to bounds 1, bounds 2. Okay. Okay, so it seems okay with that. I mean, comparing floating point numbers is always fraught. But let's get it far enough for that, I guess. Okay, we can create this class. Are you going to offer to do that? No. And I'm not at all sure about the interface, so I'm just kind of making it up. So this will be rectangle finder. Okay. He's got a constructor that takes an image, a UI image. And he's got a find method. Yeah, that's probably something more like what we got to do. All right, expected colon. Yeah. Try and get back into Swift. Is that not right? I gotta import. Come on, you import stuff, don't you? Ugh. SwiftUI? Foundation. Oh, okay. It's kind of funny to me. I mean, they've made a pretty big language. I wouldn't say it's as big as C++, but it's got a lot of pieces to it. Um, but some stuff's kind of tweaked to be useful for it. I don't know how I get this input though. UI kit? Oh, UI kit, yeah. Okay. I've been working in either Elm or Kotlin for about the last 2 months, and and Java, a little Java, but the IDE is definitely better. I haven't. I know John Reed loves app code, and they charge for it, and I just don't do that much Swift. But maybe one of these days I'll accept that I'm just in there often enough. Okay, so rectangle finder, and we said there would be a find that would produce a list of CG rect, and we'll just return nothing for now. Is it func? I don't think I need to say public everywhere. Okay. Yeah. All right. So this test should fail. Oops. Argument passed to call that takes no arguments. Okay. All right. So I should get a failing test. The Swift stuff, it seems to have some nice generic stuff that kind of works. And then this, the content view stuff, there's something interesting going on. There's this notion of some view, and it's a kind of way to, I don't know how to describe it, and I'm not fully into it, but instead of saying it's view and these are subclasses, it's like you're saying I'm producing this thing that's of this class without really committing to what it is, because it's some complex. It's got an image and a button and all these UI widgety things, but somehow they're what's going on. They're the pieces that are in there. Anyway, all right, we got a failing test. Not surprisingly. Okay. And to your point, if I could enlarge the bounds of the test data, I could make a rectangle contains. It might be, maybe we should split that up and improve our assertions before we go any further. So let's assert rectangles dot count is equal to 2, because we got 2 file cards in there. And then assert true. We're going to say let's say bounds1 dot contains a rectangle, rectangle sub 0, and bounds2 contains rectangle sub 1. And to make this smaller, let's just take off this stuff. So X, we got to make it smaller coordinates and bigger width. Okay, and then this, I think we'll just take that much off. Yeah, oops. 535. Yeah, let's okay, let's take this out. Let's hard code some answers. Would that do it? I probably shouldn't have deleted all that stuff I just deleted. Okay, let's. I'll just take a bounds 2.5 works. Wait. No, this should be 0.05. 5.25. 0.3.35. That should be okay. Let's take that. And then yeah, let's test it. Let's return that. Bounds 1, bounds 2. Was it command tab? Nope. Control I. Okay, and let's just return this. Bounds 1, bounds 2. Okay, I think that should check if it's right. I mean, this is what we're going to get from the back end, we assume, and we want to say our test will pass. Okay, that's just the old message. Let's try our test again. Whoops, I thought I deleted it. Oh, I undid my deletes. Okay. Looks like something's not right. Let's run the test, not the program. Okay, so it runs all the assertions. So this one failed. It says 0.05, 0.45 with let's make this bigger so it can't quite, because I may have moved it too much. 0.5. If I move this half of that, then I got to make sure I have at least half here. So let's do, well, let's see how this does, and then we'll. Okay, thank you. That's a great suggestion, because that would have been really tied in with all the stuff I'm doing on the mechanics of actually calling it and not finding out that my tests were okay. All right. It's 3 o'clock, so we're going to stop here. It's 3 o'clock my time anyway. We'll stop here, and next time is Sunday, 1 to 3 p.m. Eastern time. We will pick up and make, well, all this stuff from like 53 down. We're going to embed that into our thing and go from there, you know. So get this mechanical piece working, and then work on some translation so that at least some parts of these computations are not in there in the UI. All right. Thanks for joining. Yeah, Astrid, your help was great. And yeah, I think we're closing in, but we're getting real here. So I think we get this Finder working and generating some rectangles that we can use, and then we'll work on the content view and make it work. So again, thank you all. I will catch you next time. Bye-bye.